Systems of linear inequalities. In this video, you'll learn how to write a system of inequalities to describe a situation, and then find the solution by graphing and interpret points in the solution. Let's start by looking at systems of inequalities. A system of inequalities consists of two or more inequalities that share the same variables. The solution to this system include all points that satisfy both inequalities. So the solutions to this system is where the shaded regions of both inequalities overlap. So let's look at an example. We'll graph the solution to the system and give one possible solution. We'll start by graphing the top equation of y is greater than 2x minus 1. Our y-intercept is negative 1, so we'll put our first dot on the y-axis at negative 1. Our slope is positive 2, so we'll go up 2 over 1, and now we can see the line forming. Since our inequality symbol is greater than, our line won't include solutions, so we'll make a dotted line. Now we want to shade the region. Since we have greater than, we'll shade above the y-intercept. Now let's graph the bottom one. Y is less than or equal to negative x plus 3. Our y-intercept is at positive 3, so we'll put our first dot on the y-axis at 3, and our slope is negative 1. So we'll go down 1 over 1 until we see the line forming. The inequality symbol less than or greater than tells us to use a solid line, and since we want less than, we'll shade below our line. Now we can find where both of our systems overlap, and this happens here on the left in this triangle region, so any coordinates in this area represent solutions. So one example would be negative 4, positive 3, or negative 3, negative 2. Let's try another one. This time we'll use the system to solve this riddle and then identify some possible solutions. The sum of two numbers is less than 2. If we subtract the second number from the first, the difference is greater than 2. Let's start by calling x our first number and y our second number. We know that the sum of the two numbers is less than 2, so we can write this as x plus y is less than 2. And then we know that if we subtract the second number from the first, the difference is greater than 2. So we can write this as x minus y is greater than 2. Now we'll graph both of these inequalities to see where that intersection happens. But first we need to put these inequalities in slope-intercept form. So we'll start by subtracting the x term on both sides, and this gives us y is less than negative x plus 2. On the next inequality, we'll start by subtracting x again, and this gives us negative y is greater than negative x plus 2. Now we need to divide both sides by negative 1 to make y positive. As soon as we divide by a negative, we want to make sure we switch that sign. So we get y is less than x minus 2. Now we can graph both of our inequalities to find where the solution is. We'll start with y is less than negative x plus 2. Our y-intercept happens at 2, and our slope is negative 1, so we'll go down 1 over 1 until we see the line forming. The inequality symbol of less than tells us we'll have a line that's dotted since it won't include solutions. And since it's less than, we'll shade below our line. Now let's graph y is greater than x minus 2. Our y-intercept happens at negative 2, and our slope is positive 1. So we'll go up 1 over 1 until we see that line forming. Now we have the inequality symbol greater than, so this will also have a dotted line, and will also shade below. So now we can see that that bottom triangle area represents our overlap. So the points like 0 and negative 4, or 2 and negative 3 would be solutions to this riddle. Here's another one. We'll graph the system of inequalities and then identify which of the following are solutions to this inequality. Let's start with our first inequality of y is less than or equal to negative 2x plus 6. Our y-intercept is at positive 6, and our slope is negative 2. So we'll go down 2 over 1 until we see the line forming. Our inequality symbol is less than or equal to, so this will have a solid line. And then we'll shade below it since it's less than. Now let's look at x minus y is less than 6. First we'll have to put this in slope-intercept form. So we'll start by subtracting that x from both sides. This will give us negative y is less than negative x plus 6. and then we'll divide by -1 to make y positive. And we'll get y is greater than x minus 6. Notice that our inequality symbol flips since we divided by a negative. Now we can graph this inequality of y is greater than x minus 6. Our y-intercept happens at -6, and our slope is 1. So we'll go up 1 over 1, and now we can see that line. The inequality symbol used was greater than. So we'll have a dotted line since it doesn't represent solutions, and we'll shade above it. So the overlap happens on that triangle area on the left. So now we'll go through each of our options and see if it falls in that region. Our first point is 0, 0, and this does lie in our solution section. So this is a solution. Now let's look at -5, -15. So this one's going to go below our graph, but it would be cut off by that one line. So this would not be a solution. Now we have 3, 0, and this is actually right on that line. That line that we had was solid, so this would be a solution. But if it was on the other line that was dotted, then it wouldn't be a solution. But this is safe for now. So now let's look at 10, 0. This one also goes off of our graph, but we can see that it's heading farther away than our solution section. So this would not be a solution. Let's look at one more example. Jada has $200 to spend on flowers. She wants to buy roses and carnations. Roses cost $1.45 each, and carnations cost 65 cents each. Jada buys enough roses so that 75 people go home with at least one rose. So we're going to try to put this situation in terms of a system of inequalities. Let's start by labeling our variables. We'll call R roses and C carnations. We know that roses are $1.45 each, so we can represent this as 1.45 R. And we know that carnations are 65 cents each, so we'll add 0.65 C to add in the cost of carnations. And we know that she only has $200 to spend on flowers, so we'll set this less than or equal to $200. We also know that she wants to buy enough roses so that 75 people can take at least one home. So we can represent this as R is greater than or equal to 75. Now we have a system of inequalities that we could use to graph and find solutions if we needed to. Now let's recap what we've learned. A system of inequalities consists of two or more inequalities that represent constraints or relationships of the same situation. We can graph each inequality and shade the region where both graphs overlap. The shaded region represents all possible solutions.